Thank you, Mr. Chairman. As an overview, so many questions, so little time. I'm going to direct my question to Dr. Christy from my hometown at University of Alabama in Huntsville. But if anyone else wants to add any comments, please feel free. When I say so many questions, first we've got the issue of whether global warming exists, and if so, to what degree, and if so, is it cyclical or man-made? But we've also got the question about if it is non-cyclical, if it is man-made, what are the effects? And in that vein, I'd like to get your insight on some information that I received while I was in Antarctica about 15 or 16 months ago. The question focuses on sea level rise or fall. What we generally see in the news media is if there's global warming, and it makes sense at first blush, well, you're going to see ice melt and you're going to see the sea levels rise, and we're going to have all sorts of damage done to our coastal areas as a consequence. But while I was in Antarctica, I met with a number of national science foundations who all contended that there was some degree of global warming, but they added that if there was a slight or modest global warming, that the sea levels will fall, not rise. Let me emphasize that the sea levels, if there is slight or modest global warming, will fall, not rise. And of course, that was somewhat perplexing because that's the exact opposite of what we hear in the news media on a regular basis. And this is what they said, and Dr. Christy, if you'd please share your insight as to whether you think their argument is legitimate or not. First, that the principal amount of ice on the planet is in Antarctica, roughly 85% more or less of the total amount of ice on the planet. Second, that if their temperatures rise a little bit, then that air is going to carry more moisture, which in Antarctica is going to be deposited on a huge landmass that is larger than the size of the United States of America. By way of example, some levels of ice, I think the mean is around 6,000 feet deep. South Pole, it's more than that. In some places in Antarctica, it's as much as 3 miles thick. And that it takes hundreds of years for that ice that has fallen in Antarctica to actually reach the coastline, which means that if temperature goes up a little bit because of this effect, you're actually looking at more snow and ice being deposited on Antarctica and water being taken from the oceans, more than offsetting whatever melt there may be in Greenland or the Arctic. So what are your thoughts on that theory or argument that they were raising to us in Antarctica?
Well, thank you for the question, Congressman. I will yield to our polar expert here, Dr. Curry, for the answer.
Well, dadgummit, I wanted to do something with a local boy, but go ahead, Dr. Curry.
It's pretty hot in Alabama.
All right. Thank you, John. Well, the mass balance of glaciers is a complicated topic, and we have, new satellite technologies that are trying to measure this, from laser altimetry and so on and so forth. But you see glacier accumulation in some regions due to increased snowfall, and then there's a few regions where you see it melting. And this is true both for Greenland and Antarctica. The idea of warmer oceans translating into more snowfall seems to be a real one, but then there's glacier dynamics. It's a very complex situation. So there is something to what you heard, that is a real mechanism, but how all this plays out for the glacier mass balance remains, a topic of research, and it's really only, the last decade or so that we have had really, really good measurements of glacier topography, and we can really track the mass balance. So we do need the observations from satellite and also field experiments to sort out this issue.
Well, moving to a NASA study from 1992 to 2008, they concluded that in Antarctica you were seeing, while there's this global warming going on, a net addition of about 100 billion tons of ice per year. And you talk about over the last decade. Is that 1992 to 2008 data accurate in your judgment or inaccurate?
There's uncertainty, but you're seeing the accumulation over East Antarctic, whereas on the West Antarctic ice shelves, you're seeing net melting. So there's some spatial variability. And there is significant uncertainties in our estimates of all this, particularly the further back you go.
Anybody else want to add any comments to that issue? Dr. Mann?
Yeah, so we have widespread measurements now from satellites, direct measurements of the total ice mass contained in the ice sheets. And there is no question that the two main potential contributors to global sea level rise, the Greenland ice sheet and the West Antarctic ice sheet, are losing ice. And we know that that loss of ice means that the ice sheets are contributing to sea level rise already. Now, we hear so much about uncertainty, as if uncertainty is a reason for inaction. But in this case, the uncertainties are breaking against us because we are actually seeing more rapid loss of ice from those ice sheets than the climate models that many here criticize had predicted in the past. That means that we are going to see more sea level rise in the near term than the models had predicted. In this case, uncertainty is not our friend. It's breaking against us.
Dr. Mann, Dr. Curry, thank you. Dr. Christy, next time. Thank you, Mr. Chairman.
Thank you, Mr. Brooks.